how to find reaction forces by applying frame techniques, the analysis of frame techniques. Now, so far until this point, you have seen that one reaction is a pin connection or hinge connection. Another reaction is a rolling contact or frictionless surface. And that gives you only three unknowns. So the vertical reaction at point B, there is no horizontal reaction because it's a rolling smooth surface, where at A you have both the vertical and the horizontal component. So you have three variables. You have summation of fx, summation of fy, summation of moment is 0. So you'll be able to solve all three of them. However, if you look at this actual crane where this problem was simplified, so you have this boom A, C, D, and then this cylinder is trying to push this boom up and down. And at point B, this cylinder is attached to the truck bed. So it is more kind of like a hinged connection than what you have assumed rolling contact before. So at point A, here at the contact at the truck bed, also the cylinder is attached to the truck bed. So there is not a rolling contact right here. It is actually a hinged connection. So when you have a hinged connection, then you also have a horizontal component there too. So now you have four variables. You only have three equations. So you won't be able to solve just by simply applying the techniques we have discussed so far. So we'll have to apply the frame analysis techniques here. So let's show you this step-by-step process. Now, first step, you have to find as many reactions as possible, the techniques we have shown already. So simply, you can take moments with respect to any of this point and to find some of the reaction forces, or as much as possible. So if you take moment with respect to A and set everything 0, so that will give you the basically cancel everything at A. Also, it will cancel the horizontal component at B because that passing through B. So only thing we'll have is the BV. So if you take moments, the BV, the vertical component with respect to A, will do a counterclockwise moment. So that's going to be positive. So we can write here plus BV times the distance. So it is the distance from A to this B force, which is 15 divided by cosine 30 degree. So I found that 17.32 foot. And then 600 will do clockwise moment. So it will try to push down. So with respect to A, that's going to be clockwise. So the distance of that is actually half of the boom. This is the boom weight. So it's going to act in the middle of the boom, which is total 15 plus 40, 55 foot, divided by 2, and then the cosine of that will give you the line of action of that force B. So it's going to be 55 divided by 2 cosine 30 degrees. So that's the distance of 600 pounds, and the 4,000 will be double of that. So I found that is 23.82 foot minus 4,000. That will also do a clockwise moment, which is negative 47.63 feet away. Everything summed to 0. From here we can find the VV is equal to plus 11,825 pounds. So that's the reaction at B. We can apply the same technique at, you can take moment with respect to B, then set to 0. I found that the horizontal vertical reaction at A is 7,225. That is negative 7,225 pounds instead of plus. So actually this component negative 7,225. So we'll try to pull down this at point A, and point B it will push down, push up. So it's gonna balance everything. If you do summation of now Y, you can check whether this is 0 or not. So you got basically plus 11,825 at A, plus at B, minus the 7,025 to 225 at point A, minus 600 is the boom weight, minus 4,000 is the load this crane is pulling, and everything will be basically zero. So our calculation was fine here. Now we also have two more variables here. So if you do summation of fx is equal to 0, so then AH plus BH, horizontal component, everything sum to 0. We won't be able to solve it right now, so we'll have to come back later. Now we're going to apply the frame analysis technique to find the reaction force. So frame technique. To find the reaction forces. So what are you going to do, the frame technique, we already discussed that. You remove one of the component or one of the member. Let's remove the boom. So you have this. Now the vertical component at A is negative, so 7,225 gonna act downwards. We still don't know the horizontal component, so you can keep whatever that is. Now then at C, we also now have two reaction, horizontal, vertical. In the middle, the 600 acting in the middle, and then 4,000 acting right there. So now we can do summation of Fy is equal to 0. So that will be minus AV, then plus CV, minus 600, minus 4,000. Everything sum to 0. So that will give us CV, because we already know that value at vertical component at A, which is 7,225 minus 600 minus 4,000, everything sum to 0. So then I have found that CV is equal to 11,825 pounds, and that is positive, so that's upward direction. Now what we can do, we can apply moment at A and set that to 0. That will give us the value. So it will cancel everything at A. We'll have CH, CV, which we have already calculated, 11,825 pounds. So only unknown will be CH. So that 11,825 pounds will cause a counterclockwise. If you take with respect to A, it's going to do a counterclockwise moment with respect to A. So we can write that then CV times the distance of CB, which will be simply 15 cosine 30 degree. And that's a positive moment because it's doing counterclockwise. Everything else will do a clockwise moment. The 600 and the distance of the 600 is 23.82 feet. Minus 4,000. The distance of that from A is 47.63. Minus CH. The distance of that, the line of action of CH, is actually this guy, which is 15 sine 30. So it's going to be 7.5. Everything sum to 0. So then we can calculate this CH. I found CH is equal to minus 6827. So that is CH. So CH is equal to minus 6827. Now at the horizontal direction, you got, if you do summation of fx is equal to 0, you have AH plus CH is equal to 0, then AH plus CH is negative 6827, things sum to 0. So then AH would be plus 6827 pound. So now we know the horizontal reaction at A, point A. Therefore, you have the horizontal reaction at point A, which is 6827. So then the VB would be minus 6827, just to balance that. Because in the free body of the entire crane, the only horizontal component is AH and BH. So you got that. Now to verify, we can draw the cylinder and then we can do our verification. So we basically have all the unknowns. So if we do this cylinder at point B, we have the horizontal, which is to the left direction. And we previously calculated the vertical reaction at B, which was 11,825 pounds. And then at point C, remember, everything we calculated for the boom, the value will be exact same, however, exactly the opposite direction. So for the boom, the vertical component at C was upward direction. So for the cylinder, it's going to be downward direction. So that's going to be 11,825 pounds. And then at C, the horizontal reaction was negative 6827. So it's going to be positive for the cylinder. So plus 6827. Now if you look at this number, cancel this number, this guy cancel this number. So everything is checked. Now, to summarize, when you have a practical real-world situation where you have 4 reaction forces, you won't be able to solve it by just simply doing summation of fx, fy, and moment 0, because that only 3 equation will not be able to solve 4 unknowns. So you'll have to apply the frame technique. Basically, remove one of the frame member, doesn't matter which one you remove, and then as long as it has some of the one of the reaction points, and then remove that, and then you apply the frame analysis technique, then you'll be able to find all the reaction forces.